Let's move on to our next question, Lisa.
If we select a row at random from our dataset, what's the probability that the person concerned is female?
Once again, the denominator for our probability is 30,160. As for the numerator, the event is that the person concerned is female. We count those rows whose sex is female. We don't worry if she is making over 50k or under. Let me get back to my pivot table here. So one of the entries on the margin corresponding to the female row, 9781, forms our numerator. The probability of this event is 9781 over 30,160, or about a third. Such quantities are called marginal probabilities because they are computed by directly looking up the margins instead of accounting for every level of the variable. In our case, the salary of an individual has only two levels, less than 50k or greater than 50k, so it may not make a big difference after all.
Now, if there were 10 levels...
Really? We've spoken about the intersection of two events, so we can't leave out their union, can we? We ask what is P of F union O, the probability that a randomly chosen person is female or makes over 50k. From the table, we know that the event F has a size of 9781 and the event O, let's take a look, 7507, that stands for all people making over 50k. Their overlap has a size of 1112 because it's the female row intersection with the greater than 50k column. We now have the law of unions, which can be stated as follows. P of F union O is P of F plus P of O minus P of F intersection O. All of the events share the same sample space, so the denominator is common. The numerator of the LHS is the combined sizes of these two events. If we simply add up the sizes of F and O, their overlap will be counted once for every event. But we only need one copy. The law will follow. So we can compute P of F union O as 9781 plus 7505 minus 1112 divided by 30160, which is 0.54 or 54%. On the other hand, if our two events are mutually exclusive, then the intersection term is not needed. We just sum up the individual probabilities. Take for example, persons in our dataset with a bachelor's degree versus those with a master's degree. I leave it to you to figure out what their exact likelihoods are from the dataset and then calculate their combined probability. By now, you must have a fair understanding of how to go about constructing probabilities. I really hope you have developed an appreciation for the topic and you've gotten over any fears you might have had. In our next segment, we'll go over a very important topic called conditional probability. Now, given that you've been working on your exercises, you should steer through it comfortably.
And on that condition, we bid you goodbye.